So homework 2.1, question number 4, playing around with set notation. So we have our universal set here, our universe, we have sets A, B, and C. And then we're asked about this set down here. And remember the other day, I talked about different ways we can reference the complement of a set. So sometimes it'll have a little C up there. I like to put a bar over it to indicate the complement of a set. And that's just everything outside of that set. The cap here is our intersection symbol, and the cup here is our union symbol. So let's draw this out. So we have set A, set B, and set C. All of those live inside my universe. And then we know what the universe is, and we know what's in A, B, and C. So to fill in this information, it's usually easier to start on the inside. So what do all three have in common? So let's see, we have an A in all three. So that A is going to go here. Not B, not C. Looks like they have E in common. F is in common. Oops, I overlapped there. I should have drawn this bigger. F. G is in common. H is not, and I've gone through all the letters that are in A that are common with B and C. So it looks like all three have A, E, F, and G in common. All right, then we'll focus on just A and B. So that would be this up here, this crescent. So we've already accounted for some of the things they have in common. We've got A, they don't have B, we've got E, we've got F, we've got G, and that's all A and B have in common. So there's nothing else up here. If we look at, let's say, A and C, let's do B and C since they're next to each other. So over here, B and C, we've got the A written down. C is common to A, B, and C, but not A. So C would go in here. E we've got, F we've got, G we have, I is not common. So that's all that's in that part. And let's go to A and C over here. If we look at A and C, let's see, we've got A accounted for, not B, not C, E, oh no, wait, say A and C, sorry. I'm gonna do these two next. So A, B, okay, that was unique to AC. So there's a B here. E we've got, F we've got, G we've got, H we haven't written down yet. So there's an H in there too. So I've gotten their intersections down. And then what's missing? So let's see, A should have A, B, E, F, G, H. A, B, E, F, G, H. So everything in A is accounted for. So there's nothing else in A over here or there. So A is accounted for up there. B, we have A, C, E, F, G, I. A, C, E, F, G. We haven't accounted for I yet. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So those are all the things inside B's circle. And then C, looks like we're missing a few. We have A up there, we have B, we have C, we have E, F, G, we have H. The only thing seems to be missing is K is out here. So that's 1, 2, 3, 4, 5, 6, 7, 8 elements. And inside of C's circle, 1, 2, 3, 4, 5, 6, 7, 8 elements. All right, so we have B accounted for, C accounted for. Is the whole universe accounted for? Let's see, question mark, I don't know yet. So I just need to count out A through K and see if there's anything missing. A, B, C, I don't see a D. E, F, G, H, I do not see a J. K, got it. How many letters is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, looks like we got them all. So we've accounted for our universe and where the elements of set A, set B, and set C have to live. So that's the situation. Next, we want to try and play around with this right here. So the way I would do this is just kind of piece it together. So this says to find A intersects C and then get everything outside of that, the complement. So this just requires keeping track. What's in A intersects C? Let's see, A is here, C is there, and there are in sets A and C together, the intersection would be these 6 elements right there. So if I put them in order, I see A, B, E, F, G, and H. Did I get that right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so that's A intersect C. What is the complement of A intersects C? Well, it's everything that's not in that set. So now we'll just list out everything that's not in that set. A, B, C is not in there, little c. D is missing. E, F, G, H, I is missing. J is missing, and K is missing. So complement means get everything outside of that set in your universe. So that's that set right there. So we're this far in the problem. Now, before we can find the union with the other set, we need to know what that other set is. We're kind of going to do a similar thing. Let's do that one in green. So before I can find the complement of B intersect A, I need to figure out what is B intersect A. So that would be, so B and A just have these 4 elements right there in there. So that would be A, E, F, and G. And then once I have that established, what's the complement? So everything that's not in that set, that subset. And so we can just, knowing what our universe is, we can just look and get everything that's not A, E, F, or G. So we have A, so we need B, we need C, we need D, skip E, F, G, H, I, J, and K. All right, do I have all of the letters? A, B, C, D, E, F, G, H, I, J, K. Looks like I got them. All right, so now we know what this set looks like. Next thing we want to do is we want to take the union of these 2 sets right here. So what happens if I stick these 2 sets together? So the union says take everything in this set or anything in that set, and it could be in both sets. So union means it's got to be in one set, the other set, or both. So for sure, this union has to have everything I see in the blue set here. So the union of these 2 has to have C in it, has to have D in it, has to have I in it, has to have J in it, has to have K in it. And then I just keep looking. Have I written down B yet? Nope. Have I written down C yet? Yep, don't need to write it again. D, got it. H, nope. I, got it. J, got it. K, got it. All right, I think I got them all. Going the other way is B in there, yep. C, yep. D, yep. H, that's supposed to be an H right there. I, yep. J, and K. So all these guys are in there. All these guys are in there. So that would be the union of these 2 sets. So that right there Don't need that extra comma. Ooh, that's a big eraser. Is the set I desire, which is A intersect C complement union B intersect A complement. So I'm going to show another way to do that with a picture instead of listing elements at first. But one way to do it is just drawing them out and then just carefully working through one step at a time. So let's look at another version of that. So what I want to do is draw a picture of this set in a Venn diagram with some highlighting. So let's put that up here. And then let's draw out our universe. And then we need a set A, a set B, and a set C. And then I might need a copy of that because this could get a little messy because we're solving a problem. Problem solving is often messy till you figure it out. All right. So similar to before, I'm just going to kind of look at the picture and figure out what A intersects C looks like, and then its complement, what B intersect A looks like and its complement, and then what the union looks like. So I'm going to use a highlighter to do some of this. So A intersects C. So here's set A, here's set C. When I intersect them, I get only where they overlap, which is this region right here. The complement would be everything outside of that. So the complement is everything out here, outside of that intersection. And I'm just going to use my eraser to clean this up a little by erasing a little of that in here, because that is not part of it. Okay, so I just attempted to highlight. Let's get back to the highlight. A intersects C complement. So I found the intersection, and then I looked outside of that. And so that's that yellow striped region. Everything outside of that crescent right there. I'm going to do the same thing with B intersect A and its complement. So let's try my blue highlighter. Is that blue? Yeah, so blue for this. So B intersect A. BA, okay, so that would be this crescent right here. Be a little more careful to go outside of it. And then I want to look outside of that crescent. So I'm going to go vertical for that one. All right, so I'm just shading everything outside of that crescent with these highlighted stripes. And then I want to consider the union, which just means put both of those together. So on my picture, the union is anything, or any region, I guess I should say, with yellow or blue stripes. And remember, the mathematical or, it could be both yellow and blue stripes is what I want there. All right, well, whenever you split up a set into 3 subsets, like my universe here, I'm just gonna do that over here again. Actually, I made a copy of that, didn't I? I can just paste it in. Oh, undo, oh no. Oh, really? All right. Order of operations matters, paste it in and then move it. So whenever you take a set and you break it up into 3 subsets, you break that region up into a bunch of discrete areas. Like if these were fences, then I have this one big region on the outside, and then I have 2, 3, 4, 5, 6, 7, 8 regions that don't overlap. So I have, if those are all fences, I have these separate corrals that stuff can live in. And so which of the corrals up here have yellow or blue highlighting on them? Well, I can see in my picture, I'm just gonna get my red to circle it. Region 1 on the outside here definitely has yellow or blue highlighting. This region right here definitely has yellow and or blue. So that is definitely part of my union. This region right here has yellow, and so that meets the or idea. So that is definitely part of this. This one right here has yellow or blue. So that's definitely part of this union. This region right here has blue, which meets my or condition. So that's in there. This one in the middle that I called region number 6, that's got nothing, no highlighting. It's not part of my union, skip it. 7 here has, let's see, it looks like yellow and blue. That's in there. And 8 has yellow and blue. So it looks like this union is everything but the intersection of all 3 sets there. Everything except that right there. So now let's double check that solution. If I look back at where I wrote all of the elements. So my claim is that this set down here is everything except A, E, F, and G. Right? A is not in there, E is not in there, F's not in there, and G's not in there. All right, so a couple of ways to approach these set problems. One is I listed out all the elements carefully in the right places, indicating what they have in common, what their intersections were. Once I did that, you kind of have to, like most math problems, you kind of work from the inside out. I had to say, okay, what is this set there? Now I can find its complement. What is this set here? Now I can find its complement. Once I know those two, I could then finally find the union. Now my pictures took a different approach. Instead of looking at the elements to do that, I just kind of thought about this thing and I just identified where is set A intersect C? Where is its complement? Where is set B intersect A? Where is its complement? And then the union means just grab everything that has yellow or blue stripes and you're done. 2 different approaches led to the same answer. Now, sometimes one way is easier than the other. Sometimes they're both just hard. And this problem is just a tough problem.